glad to be here. Today I'm going to talk about Caffe2 framework for mobile and embedded deep learning. So here is the outline. First I'll talk about what Caffe2 has been doing on mobile, what's been successful over there. Then talk about the ONNX, the Open Neural Network Exchange format. And finally, I'm going to talk about Caffe2 on embedded, mostly from the benchmarking perspective. We haven't done a lot on embedded, so that's the area that we are trying to get into, and we want to hear some early feedback about the approach. First, Caffe2 on mobile. So Caffe2 is a lightweight, open source framework for deep learning algorithms. It is primarily designed for production use cases. So within Facebook, we use Caffe2 on server side quite a bit, and on mobile phones quite a bit also. So that's why speed is our top priority. We optimize for speed very heavily. And it has C++ and Python-based interfaces. So Caffe2 is built from the very beginning, has mobile in mind. We support different platforms such as Linux, Mac, iOS, Android, and Windows, or even on the embedded side, the IoT devices, Raspberry Pi, Tiger X1, etc. So on mobile, the mobile space is very fragmented. You can easily find 20 plus chipset vendors, 25 plus CPU microarchitectures, although most of them are ARM architecture, and 15 plus different GPU architectures, and 2 major operating systems, iOS and Android, and 3 major graphics APIs, OpenGL, Vulkan, Metal, and 2 major compute APIs, OpenCL and RenderScript. So this is a very fragmented space. And what have we been doing over there? What should we deal with that? So similar to other frameworks, Caffe2 has multiple backends, so that when you design your neural network algorithms, you only need to focus on the model side instead of worrying about how they will be deployed on different backends. So just a brief introduction about all those backends. On the mobile CPU side, we have NPAP, and on mobile GPU, we have ARM Compute Library, we have Metal for iOS GPUs, Metal MPSCN, Qualcomm chipset, we have a Qualcomm Snapdragon MPE, and for NVIDIA, we have CUDA. And on the mobile side, for the CPU, on the ARM processor, we use Unpack, which is a fast convolution algorithm. It uses a Winograd and to speed up 3x3 and other convolutions. It takes advantage of the ARM's Neo microkernel to use the SIMD calculation and optimizes for the multi-core and a bigger little core. On the iPhones, we take advantage of the GPU acceleration to use the MPSCN and Metal kernels. It performs best on iPhone 6s and later. If you use Android phone and use Qualcomm's chipset, we use the Qualcomm Snapdragon MPE, which supports the Qualcomm's Adreno GPUs, which runs on top of OpenCL. And using the same thing, we can potentially use it to run on Hexagon DSPs, so GPU can be freed for other purposes. So here is just one example that we have a classification algorithm running on mobile, and if we run it on CPU, we can get 12 frames per second, which is already very good. But when we run it on the GPU using the Snappy, we can achieve 50 FPS. If you don't have Qualcomm chipset, no problem. We also have the ARM Compute Library, which works on newer Mali GPUs. for GPUs from Samsung, LSI, MediaTek. They have those kind of GPUs, which utilizes the OpenGL 3.1. And just to give an example, the person segmentation model that runs on the phones, if we run it on CPU, we get 50 FPS, already very good. When we run it on ACL, on compute library, we can achieve 71 FPS if every frame the data is transferred from CPU to GPU. If we don't do that, the entire pipeline is inside GPU, we can get 133 frames per second. So our story on mobile is, the way we deal with mobile is we engage and collaborate with a few vendors closely. We can pick, on the mobile space, there are some companies have more chipsets than others, so we pick a few and work with them very closely, ask them to support Caffe2, and then we iterate on performance with them. So we have people working on our side, and we have people working on their side, and we have frequent meetings so to improve the performance. It works so far very well, but there is one problem with that approach, is that it doesn't scale. Especially if we want to go into the embedded area, then we have engineering is actually quite small number. We cannot really deal with small companies. So I'll talk about that later, but before we go to that, let's talk about the ONNX, the Open Neural Network Exchange format that we are proposing. So in the current neural network and deep learning area, we have a lot of frameworks, as just said. We have tons of different frameworks. Like Facebook has two, PyTorch and Caffe2, and then other companies has more. TensorFlow, MXNet, CNTK. So in a grand scope, that they are pretty similar, but there are differences. Especially the model formats are very different. So when you do training on one, using one framework, you cannot even port to another framework. And on the other side, on the hardware vendor and the numerical library side, we have a lot of different choices as well. So just to give an example, that like Apple Core ML, NVIDIA TensorRT, computer library, Qualcomm Snappy, and many more. So if we draw a line between each of the framework to each of the vendor, that's n square pairs. And for each vendor, they're actually very confused which framework to support and how to support them, because they also have very limited resources. So that is our current situation before. And within Facebook, we have our own need, because we, as I said, we have two frameworks. We have PyTorch, which is developed by FAIR, Facebook AI research, and which is Python-based with GPU acceleration, very flexible, and you can design new models and new operators very easily. So researchers like that. But when FAIR develop a very shiny new model, how does the Facebook production take advantage of the new model, which is primarily the Caffe2 stack? And that is actually not so easy process. So the old way of doing that was, well, you have the model, we know what it is, we have to re-implement everything in Caffe2, either the new operator or the new model. And then we need to retrain using the same data that the PyTorch has been trained on Caffe2, and hopefully we get the equivalent quality model, and then we can deploy that to the production. But that process may take a long time. It may easily take weeks or even months just to go through this process. So that is a big problem, so that's why we propose to use this open neural network exchange format. The goal is to enable interoperability. Basically, from the industry-wise, it is cross-framework and hardware vendors. And from the Facebook inside, it is cross PyTorch and Caffe2. So now with the ONNX, you don't need to worry about what to support. You can support them all with this bridge of Onyx. You support Onyx, and then the Onyx will have model conversions from this framework to the other framework. You can train it on this framework, and then port it to Onyx, and then convert it to another framework, and deploy, which is very easy. So instead of n square pairs, we can, you only need to worry about n pairs. So within Facebook, as I said, Onyx actually streamlined the process from research to production. So Fair does research on the model, and once the model is finalized, you can easily serialize that into an Onyx format, and then the Onyx format can be converted into Caffe2 format, and then from the Caffe2 format, we deploy that in production. So the process can be shortened quite a bit. So that is Onyx story. So then we talk about the Caffe2 on embedded. We just starting to look at the embedded area, and when we look at the mobile, it's already very fragmented. And when on the embedded, it is even more fragmented. We have many chipset vendors, a lot more, and many DSP architectures, many proprietary architectures, and a lot of different operating systems, even proprietary APIs, many design flows. So that's a sea of choice that we have to deal with. So how do we take these challenges? So obviously, the approach that we work with the mobile companies does not really scale for embedded. But we still want to work with the embedded vendors, at least to share what kind of machine learning models that we care about. And we want to help the embedded vendors to enhance the machine learning model performances, and also assist those vendors to evaluate against market. So that's why I'm going to talk about this AI benchmarking that we are working on. So it provides a model view on the important models, and it normalizes the benchmarking metrics, what we care about to measure, and the benchmarking conditions, and what condition we measure. And also we want to automate this benchmarking process so that you don't need to do a lot of things manually. So everything should be script or code basis. And also it provides some honest measurement on the performance. So right now it is mostly focused on inference. Maybe in the future we will work on training, but I guess for the embedded, mostly is for inferencing anyway, so that is good. So just to give an illustration about the goal of this benchmarking, suppose we have some starting point. We have different models. Each row is a model, and then we have different mobile phones. So we've been working on the mobile. That's what we have the numbers for. We hope to have some embedded processor numbers in the future. So that's, and then whenever we add a new model, we need to generate new numbers for all the existing platforms. And we hope to generate them automatically without people doing manual work. You just need to upload your model and specify what you want to measure in some metadata, and then the platform, the benchmarking will just run on all the existing platforms and report the data. Similarly, when you add a new device, and we should generate all the numbers automatically as well. All the numbers on all the models automatically. So you just plug in your new phone, and then the benchmarking will start running on all the existing models. So that is the goal. So there are 3 steps in this benchmarking. First, we have a model zoo, as I say. The model saves in the cloud, and there's a centralized place to specify where the models are saved, and which metrics we want to get, and what conditions we want to get the metrics. And then we have the GPU, we have a lot of different backends, like a GPU, CPU, phone, and embedded. This centralized location repository of cloned into different of the backends and run on these backends. we have to note that each backend has its own unique run environment and building environment. So we want to make the vendors easy to plug in their code. So the benchmarking platform is written in a way that you can, everything that's vendor specific are encapsulated inside the directory. So that is has to be done distributed. And after that, when the metrics are collected, they are all sent out they can be saved locally, can be displayed on screen, or sent out to their centralized place so that we can filter, we can display. So that is the flow of the benchmarking. The current status is we have support, currently, as I say, so we develop internally for our internal use cases first. So we support Caffe2. And then we support the model format is Caffe2 and Onyx. Onyx is just a converter from Caffe2. And then all the backends that Caffe2 supports, that we support, and all the software libraries that Caffe2 supports, we support. We really need some community help that we can make it to support other frameworks or other backends. So this benchmarking framework is written in a way, hopefully it is framework and backend agnostic. So we can, in the future, we can support other frameworks like TensorFlow or MXNet, etc. But there are some work needs to be done. Just to give some resources. So everything is in GitHub. So the Caffe2 is in GitHub, Onyx also in the GitHub, and the benchmarking is also in GitHub. Currently it is under Caffe2, a repository. Maybe later on it will be moved out. So that's to be a real framework agnostic. And we have model zoos on the GitHub as well. So maybe later on during break, I can give a short demo about how we run it on some phones, and then you can get some first-hand experience of that. With that, I'm open for questions.
Thank you very much, Fei.